Hello friends, welcome back to Digitalk. So before I start the session, okay, just an announcement that I have enabled the membership in the YouTube channel. Okay, that is available with a very bare minimum cost. Okay, just to support the efforts because it takes a lot of time to identify the content and to create the videos and then to publish the videos after editing. Okay, so just to get a certain some support on that. Okay, we have enabled the membership. Okay, you can join the membership because now the multiple sessions will be available on the membership section only. Okay, so it doesn't mean that there will not be any useful content on the free sessions. Okay, there will be multiple. You will get a lot of free sessions as well continuously. But apart from that, there are certain kind of a content that is going to be published specifically in the membership section. Okay, so now in the previous session, 1 to 6 session of the thread dump and hogging thread analysis, okay, I have covered the complete end-to-end detail about the different kind of a conditions along with the what is the thread dump, what is hogging threads, and then how what are the different kind of a scenarios that can create the stuck threads or can cause the hogging threads. What are the different kind of a reasons, internal reasons, external reasons, and then in the last three videos, 4, 5, and 6, okay, I have explained with the real-time code execution and by taking the thread dump, and then I have provided few customized command, okay, that you can utilize to analyze the thread dumps. Okay, that will give you some important information immediately. Okay, if you are getting some deadlocks kind of a conditions in your stuck thread dump, or if there is a thread which is causing multiple other threads to get stuck, okay, that you can quickly get with the help of command that I have shared in the previous session 4, 5, and 6. Right. So now in continuation of same, what we are going to cover today is about the self-tuning thread pool size, or what is self-tuning thread pool. Okay, and along with the work manager. Okay, and then we'll continue this sessions. Okay, discussing specifically on this the thread pool, self-tuning thread pool, and then we'll continue on the work manager. What are the work managers and how this thread pool and work managers are related with each other. And along with that, multiple more important informations about the thread and executions, which is very important from the performance tuning and overall administration perspectives of your threads in the WebLogic server. Right. So now in the WebLogic, okay, we have the self-tuning thread pool. Okay. So what is the meaning of the self-tuning thread pool? It's a pool of threads, okay, which tune automatically. Right. It is very clear from the name as well. Self-tuning thread pool. Okay. So for example, just let us say an example. There is a thread pool. Okay, pool means ready to use threads. For example, I have for suppose we have 100 ready to use threads. Okay, so when I say ready to use, that means they are active threads. Those are waiting, okay, to get the request from the client so that it can process the request. Right, so they are ready to use threads. That means they are taking your server resources, right, because they are the active threads. Right, and each thread process the request. So when a thread process the request, that means your thread need some RAM of your system. It needs some your CPU core time, right? So if we have 100 active threads as currently, that means each and every thread is going to take certain kind of a server resources. Okay, you can compare it with the data source connection pool capacity. So if you have an idea what exactly is data source in WebLogic, okay, it is a pool of ready to use connections, right, which established with the database. For example, if I have a data source connection pool with the capacity of 50, okay, that means the 50 connection will always be established with your data source with the database. That means 50 connection will be always connected sessions. That means the 50 sessions are taking the resources of your database along with the your empty server, middle tier servers. Similarly, if you have 100 number of active threads here, so these all 100 threads are taking your server resources. Okay, and now your WebLogic will automatically increase or decrease the number of threads in your self-tuning thread pool based on the internal logic. Internal logic means the number of requests that is getting processed by your WebLogic server, okay, or the number of requests which is coming in your system. Based on the demand, if the demand is very high, WebLogic will automatically increase the number of threads in the pool. If the demand is low, your WebLogic will automatically decrease the number of threads from the pool. And why it will automatically decrease? Because if the threads are there, okay, they will take the server resources unnecessary. So it is always good to drill down the number of threads, active threads, when there is no use or no demand. You have to only increase the number of threads, okay, when you have the number of multiple requests coming in your system, right? So this is the self-tuning thread pool, where the pool is automatically tuned by your WebLogic server. So in the earlier versions like 88 and then till 9 as well, okay, we had the multiple other different kind of a thread pools, okay, and along with that there are the multiple execute queues. The second point apart from the thread pool what we have discussed, okay, which is called the execute queue, okay. So every request which come to your WebLogic server, this is your WebLogic, every request which come to WebLogic, okay, it put in an execute queue. This is called the execute queue. Okay, so every request put in execute queue. So in the older versions, we had the liberty to create our own different queues, Q1, Q2, Q3, based on the multiple our requirement. But now we have only single execute queue in your WebLogic, which take care of both. Both means your application request along with that internal administration request. You may be connecting to WLST, you are trying to start stop your servers, the multiple servers in the clusters are talking to each other, right? And then along with that you have multiple applications are deployed. So every request is served by only a single queue. There will be only single queue. So that means there is no option to create multiple queues, only a single queue. So now in a nutshell, what we have in the tuning thread pool tuning, specifically WebLogic, we have a self tuning thread pool. Along with that, we have a single execute queue, where every request is coming to a single execute queue. Okay, and it is getting processed by your self-tuning thread pool, where we have a multiple threads, and each and every thread is getting automatically increase and decrease from your thread pool based on the internal processing or internal logic of your WebLogic server. Right. So what is the next and what we have learned? Let me first quickly recap the summarize, okay, the two things what we have learned, and then I will jump into the next one. Okay, so let me open the new tab. Okay, so what we have learned: self tuning thread pool, and along with that we have a single execute queue, right? This is a single execute queue, and we have a single thread pool for execution of the request. Now most of the people think that WebLogic has a self-tuning thread pool, so it will automatically increase the number of thread as soon as required, and there is no limit of that, but which is not true. It is a self-tuning thread pool, but there is a limitation of the self-tuning thread pool as well, which is the 400 threads per server. That means each and every server in your WebLogic has a limit of 400 max threads in your self-tuning pool. Okay, and which is a configurable. If you want to increase this, you can change it from the WebLogic console as well, which I will show you in the next session along with few more details. Okay, so 400 is the limit of your self-tuning thread pool per server, each server. If you have a 4 managed server in your cluster, okay, so it will be 4 into 400, that means total 600 number of threads, 400 server each in your self-tuning thread pool. Okay, and when we talk about the execute queue, where every request coming to your WebLogic server, okay, is getting land up in your execute queue. So there is a limit of this execute queue as well, which is somewhere around 600, 356, or I don't remember exactly, but it is something 65,500 or 65,356, somewhere like this one. Okay, so it's somewhere around 65K. Okay, so this 65K is the limit, okay, or you can say the total number of requests that can be in your system at a time. Okay, so this is 55,536, somewhere around, like this is the exact. Okay, so that means this number of total requests can be stay in your queue at a time. Okay, and this could be your request which is getting executed as of now, or maybe the request which is waiting to get threads, right? Because but I said 400 is the limit of the threads in the self-tuning thread pool for each and every managed server, for each and every server, including your admin server. And total number of requests that can be queued is 65,536. So your requests are landing up, your thread is getting allocated, executing, and the thread is getting back to your pool, and then next request is taking the thread. So 65,000 around requests can be stay in your single queue, what we have in the WebLogic. Okay, and as I said, it could be a request which is getting executed, or maybe the request which is getting waiting to get the threads to be allocated for the processing. And if the total number of requests which is serving by your servers increase this 65k, the rest of the requests will start getting rejected on top of this one, right? So this is your self-tuning thread, and then single execute queue. What is the limit of both, right? And now apart from that, I will show you in the next sessions how to configure this request and how to configure and view this request as well for the queue length. Okay, now the next question is, we have 400 requests of threads in the self-tuning. Okay, now apart from that, when a thread is run, and we can say we have multiple kind of a states of a thread. Okay, specifically we have a running thread, and then we have ideal thread, and we have standby thread. Running thread, ideal thread, and standby thread, and this standby thread has a limit of 256. There is a capping of 256 for the standby thread. Now out of this 400, what all threads will be your part of your running thread, ideal threads, or standby thread? What is the meaning of this standby 256 number of threads? How this 400 number of self-tuning threads are related with 256 threads? Okay, and then on top of that, we have the work managers where we can configure the application specific threads, where we have a minimum or maximum constraint we can define to our application. So now on top of your this self-tuning thread, we have application specific thread which we have defined in the work manager. So is it going to be part of this 400 only, or it is going to be separate? If this 256 number of thread which is in standby, does it mean that this 400 number of thread self-tuning thread pool can increase on top of, if the request is exceeding 400, can it go with 256 more, or this 256 is part of the 400 only? So there are certain kind of a questions. Okay, and how it works, that I'm going to cover in the next session in detail. Okay, along with multiple more information which is very interesting, specifically to understand the self-tuning thread model and specifically your work managers, and how you can define the work managers, and how you can tune the different kind of a capacities with the help of work managers, and how you can tune your execute queue and the self-tuning thread pool.